Hey there now, and welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name of news, as we bring you the most detailed imagery of the closest star and comprehensive space weather you'll find anywhere in the world. And thanks for tuning in, by the way. We're frankly surprised that you've found the channel. So here's the sun in two wavelengths, ionized helium and iron there, 304 plus 193 angstroms. And we've got a massive filament fest going on. Check out this prominence in the southwest. We're going to start out with some close-ups here of the southeast. Well-defined coronal hole of south pole orientation down here. Another one up crossing the equator. Flaring activity has dropped a little bit as well as the radio flux. We've got some new sunspots to get named today. There's your northeastern limb. Huge filaments on the Earth-facing portion of the solar disk right now, suspended by massive magnetic fields in the solar corona. Here you can see one of those really well-defined filaments up here. And we had one named yesterday. Shout out to Nay for naming the one of the filaments there in the southern hemisphere after Kurt Russell. Yes, we named filaments after living people on the channel. Seemed like a brilliant idea, so we decided to go with it. So here is that's pretty much a money shot right there, the southwestern limb, featuring two well-defined coronal holes and a massive prominence down there in the southwest. And of course, you can see that's what you'd call a large prominence there. It's about 20 Earth diameters. All right, so let's break out some additional imagery here. Again, we do have some new sunspots to get named, like this newly formed group right here. And also this group down here. So a little bit of an uptick there in sunspot activity. This group has evolved a little bit. It's grown since yesterday. This group has evolved and grown a little bit since yesterday as well. So here are the colorized magnetogram data from SDO. That's yesterday plus today as well. February 23rd and 24th. All right, so let's take a brief look at what's going on Crescent Earth. See what volcanoes are erupting, and Shivaluch continues to explode and produce a 13,000-foot plume of volcanic ash. By the way, that image there, that's Subanose Jima. Shivaluch producing a 13,000-foot ash plume, flight level 130, flight level 140 over Abiko. Subanose Jima, 6,000-foot ash plume. Also some pyroclastic material and lava bombs coming from Subanose Jima. Flight level 060, 6,000-foot ash plume. 20,000-foot ash plume over central Mexico from Popocatépetl, as Popocatépetl explodes and produces a flight level 200. Fuego in Guatemala exploding, flight level 140. Sangre and Revenador in Ecuador there, both exploding. Flight level 200 over Sangre, flight level 160 over Revenador, and Sabancaya in Peru, exploding, flight level 250. It's a 25,000-foot ash plume. Please do not pole vault the caldera. We'll also look at earthquake activity here. And the largest quake of the past 24 was a 6.3 at Indonesia. There's a location of that. 6.3 magnitude quake. That one came in at 2:48 Universal Time this morning. We also did see a 5.3 in Argentina within the past 24 hours of streaming this video. There was also a 5.0 at the Central East Pacific Rise. Again, that 6.3 came in at, that was at 2002. That was at 2002 yesterday evening, 20:02 yesterday evening Universal Time. And just continuing up the list here, we'll cite anything over a 5 magnitude. And before we get back to space, a quick reminder, we are going to have a guest on tonight. We're going to do a video chat, a discussion with Scott McIntosh, Deputy Director of NCAR. We found him on Twitter, as we are part of the Space Weather Twitter community. And we noticed some interesting tweets by Dr. McIntosh. He heads up the National Center for, or he's the Deputy Director of the National Center for Atmospheric Research. Their website is ncar.ucar.edu. And we'll be talking about things like Terminator events. So it's super important to understand the magnetic field interactions in a way that has predictive value, because the purpose of science is to be able to forecast the future. So this is super important as it involves solar cycle length, magnetic field interference, and real ways to predict solar cycles, unlike a lot of the nonsense that you might have been listening to on YouTube. So there's a great article about it also that explains it quite well. So just do a search for the termination event, published back on June 11th, 2021. It's in the spaceweatherarchive.com. You can read all about the Terminator event. And so look for that video being uploaded tonight, as we see perhaps the largest solar cycle since the 1950s. But we're certainly seeing a solar cycle that is quite significant indeed. So getting back to space here, this is the past 24 hours in SDO 171 angstroms wavelength. And thanks for leaving comments, Tinman1057 and Mike Bordages. Good morning to both of you as well. We've also added 131 angstroms to this wavelength, so 171 plus 131 will help at showing solar flares. As 171 is pretty lousy at showing solar flares, 131 angstroms is great at showing solar flares, so there is that composite. Again, we'll have some new sunspots, at least 2 new named sunspot groups, according to my calculations today. And the 10.7 centimeter radial flux has now dropped down to 148 solar flux units. There you go. There's the 1-year graph to put it in context. I believe yesterday I said it will not drop below 147. So how's that for a forecast? That's called looking at sunspots and making an estimation in an educated fashion based on the number of umbrae that I see, for the most part. So that's the situation there for the past year. The black line is the 10.7 centimeter radial flux. The red line is the sunspot number. We should see a little uptick in the sunspot number today, maybe approaching 130, something like that. Space Weather Enthusiast dashboard here forecasted a little bit of geomagnetic unrest this morning. We didn't really see that happen. And we do still see an elevated coronal hole high-speed stream. All right, let's take a look at some geomagnetic data here. Here's Earth's geomagnetism. That's your KP index. Very calm here. KP1 is the current situation. And let's take a look at Earth's magnetic moment from space. Again, we still do have an elevated solar wind. So this is the last 4 hours of likely magnetohydrodynamic pressure, as modeled by University of Michigan's Geospace Model V2.0. That's all based on the data from the Space Weather Modeling Framework. If you want to read about that, click on the Details tab down here at the bottom, and that'll provide you the software to analyze the data yourself, if you like. Next, Earth's magnetic moment from the ground. These are ground magnetic perturbations. Again, things quite calm on planet Earth for the past 4 hours. And let's go to the real-time solar wind. And a quick reminder, folks, The real-time solar wind is measured by spacecraft orbiting Lagrangian point 1. So don't get it confused with earthly data, as the ACE and Discover are orbiting this gravitational equilibrium point known as Lagrange 1. They are outside Earth's magnetosphere, since you can't really measure the solar wind from inside the Earth's magnetosphere. And here are those data. So this is a little bit of a subsiding here. The solar wind got all the way up to about 616 kilometers per second at one point. I can't really get it to stop there, but 615 kilometers per second was the peak of this coronal hole high-speed stream, and now it's subsiding a bit here, now down to right around 500 kilometers per second at the moment. Solar wind density just under 9 protons per cubic centimeter. So that's the current situation there as the coronal hole high-speed stream continues. Next, looking at some magnetometers here. There are the GOES 16 and GOES 18. And now, once again, these are inside of Earth's magnetosphere. So that's Earth's magnetic field. And we do see some choppy readings there on the GOES magnetometers. That is typical of coronal hole high-speed streams. And those arc jet moments there, those are the satellites using their thrusters to maintain their geosynchronous near equatorial orbits. Those arc jet moments are the creation of plasma, which can affect the magnetometer readings. Continuing on to look at solar magnetism. This is the heliospheric current sheet, and Earth is solidly in a south pole oriented current sheet. Welcome to the south heliospheric magnetic pole. No changes expected anytime soon for that. And let's take a look at some additional Gong 2 data from the National Sunspot Observatory. Let me load that back up again. It unloaded for whatever reason. There's our line of sight field plot. You can see the sector boundary there moving toward the west. That is the boundary between North and South Pole. And that moves us to coronal holes. So here's our coronal hole line of sight plot. We've got a bunch of South Pole oriented coronal holes here facing Earth. Let's take a look at those in 211 angstroms from SDO. So we've got mostly South Pole oriented coronal holes here. This one is the North Pole. So we are still waiting for that field to leave the North solar heliographic pole. These are south, south, and the sector boundary is like this. So this is actually a North Pole coronal hole. Anyway, we've also added a close-up. Also, keep in mind, folks, coronal holes are solar radio jets, as there are protons blasting out of there. Coronal holes are the source of high-speed solar wind. There's some great imagery of that, as well as the filament. Down in the southwest, down here, great filament view there. Those cavernous coronal holes, keep in mind they are mainly only visible in ultraviolet light. They were not discovered until the early 70s, I believe. They show us the solar polar field reversal process. So let's move to sunspots next. But before we do that, take a moment to visit our links. If you haven't seen our links, we do have a Redbubble shop. So you can see our products in order of best selling. If you click that link, and keep in mind, folks, the channel is apolitical. So just so you're aware. And if you'd like to support the content, please consider becoming a member of the Smash Team at smashomash.com/Smash Team. That is our subscription services site. We launched it back in October of 2021. The best value is the gold annual paid-up subscription. And if you want to know about the mechanism that we think drives the solar cycles, well, become a gold member. You can read our posts about the paper that we are in the process of composing to explain the solar sunspot cycles. It's kind of important if it passes peer review. It'll just be the most important paper in hundreds of years. You can also find below the video links to the Hemp Lucid shop, so check that out if you're in the market for some mushroom gummies or some CBDs or whatever. Lots of products available there from Hemp Lucid. And now we've gotten to sunspots. So again, we'll have, I believe, at least 2 more new named sunspot groups. We'll show you those here in a moment. Likelihood of major solar flares is very high here. So we've got a lot of activity right between the Earth and Sun. And the likelihood of coronal mass ejections is very, very high also. So we'll be showing you filaments here momentarily. First, let's take a look at sunspots. So we've included 131 angstroms here again to show the flaring activity. Let's zoom in a little bit closer there. So these sunspots, these 3, are quite active in terms of producing solar flares. And yeah, we may see a large solar flare. Indeed, those sunspots are all very magnetically complex. They're all beta gamma or beta gamma delta class. Here they are, just the umbrae, the SDO continuum. And we may have 3 new named sunspot groups today, but I expect this one, and possibly this one to get a name today. So a little bit of an uptick there in the sunspot number and likely in the radio flux also. That imagery is the last 24 hours, by the way, like most of our custom HelioViewer movies. Next, looking at energetic particles here, and the proton flux remains flatline, so no spikes in relativistic particles there showing up at the GOES 16. And there is the X-ray flux. It's actually come down a little bit. This may uptick a bit. Again, we've got some new sunspots, and some of them are quite magnetically complex. Some of them are already producing some flares. So let's take a look at our flare wavelengths, 94 plus 131 angstroms. And we'll zoom in a little bit once again. How many money shots can you have in one video? Well, apparently not very many, because we make just this side of nothing to produce the content. So consider becoming a member of the Smash team to help to increase the probability that the Smash News Network Least Busted Name of News will continue to exist and produce content that's publicly visible and free for all to view. Next, we're looking at a star chart here, as we're interested in what's going on overhead. And this is what's going on overhead in Lehigh Valley. Just press the Now button, and the sun only a few degrees off the horizon there, chasing Mercury and Saturn across the ecliptic. Let's do a solar system forecast. So here's where our bodies are currently. Let's advance this 1 week. There's where things will be on a March 3rd. On this lonely side of the solar system, lacking planets in general. Next, we'll look at some coronagraphs. So here's yesterday, and it was actually quite a calm day for coronal mass ejections. Only minor ejecta showing up there on those frames. Here are some more frames from today, 33 more frames. Looks like some missing data there. So that's suboptimal, but we'll take a look at stereo A as well. Here's stereo A on the left and Soho Lasco C3 on the right. We'll let those play through. Please note the time and date stamps in the lower left. So yeah, no significant CMEs to speak of there. just minor ejecta coming out of the solar disk. Here's the past 24 hours in composite. You have the SDO 304 angstroms wavelength and the SOHO LASCO C2 and C3. Let's zoom in a little bit. A little bit more ejecta showing up there on our Helio viewer movie than the basic SOHO LASCO. Here's a little closer view. And yeah, these sunspots here moving right into the center of the solar disk here are quite active. So don't be surprised to see major flares, including the possibility of Earth-directed coronal mass ejections. Let's talk about filaments next. And we've certainly got our share. Let's bring up the latest imagery from Cerro Tololo, Chile. So this filament down here is called the Kurt Russell. And there are a bunch of filaments that could get names, like this prominence, this filament up here now becoming a prominence, also several over here, this one up here. There's a prominence up here yet. So lots of filaments to be named. Let's bring up the latest image and then invite our viewers to join us over on Twitter, the ultra broken junkware platform on which you can name that filament. We name them after living people. And follow the hashtag space weather and hashtag name that filament to see the posts. We're all over the internet at Smash-O-Mash. By the way, you can also find the link. There's a new link now to the free mushroom gummies giveaway. So you can find that pinned to the Twitter page. If you want to try out the Hemp Lucid mushroom gummies, check it out. There's what you'll see when you click the link, and there's what you'll get when you order the free products. Here's the past 24 hours in 304 angstroms alone. Major filaments and dozens of them in between Earth and Sun at the moment. So very high likelihood of CMEs, very high likelihood of solar flares. It's an exciting time to be doing space weather. And as always, it's an exciting time to be debunking utter nonsense about space weather. So that's always fun too. Here's the GOES 16 SUVI for the past couple of hours. And you can see some activity in this sunspot group down here in the southern hemisphere. Keep in mind, folks, when a CME happens right from the center of the solar disk, it's often very hard to see because there is very little contrast. Sometimes it even hides behind the coronagraph, making it nearly impossible to see. It would be great if stereo A was a little bit closer to Lagrangian 0.5. Anyway, let's continue on to our bonus feature segment here. We don't want the video to be too lengthy. Here's our space weather, and here's our satellite community dashboard. And no charging hazards here at the moment. It's smooth sailing for satellites. We got into warning levels for the electron flux here for a little while, at least for the GOES 18's measurements. GOES 16 just toying with warning levels. And we may see these levels rise a little bit higher today. This is a further indication that the coronal hole high-speed stream is subsiding. The GOES 16 and GOES 18's measurements are from a geosynchronous orbit. However, they use radiography to measure the electron flux at the F layer of the ionosphere. So there's the forecast. NOAA expecting a big uptick in the electron flux here. And there's the one-year chart to put it in context. Next, we'll show the layer where that is measured. The F layer of the ionosphere, which is at about 300 kilometers of altitude. We'll show both the vibrational frequency and the anomalygram. Not sure why no other space weather channels ever talk about the ionosphere, except in theoretical terms. we actually show the data. It's just one of many data points that we've immersed ourselves in and ended up with answers to questions not asked. So that's what happens in science, folks. You ask questions, you typically don't get answers to questions asked. You end up with more questions and answers to questions not asked. That's the way it typically works, as people tend to work on the same problems for extended periods of time until they're solved. I mean, in 2019, a crack YouTube unit went to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade to the internet underground, where survivors produces a fortune if you have a problem, if no one else can help. And if you can find the videos, maybe you can hire the Smash team. No, you certainly can hire the Smash team. Check out the low-frequency anomalies around southern South America, the Southern Ocean, Antarctica, etc. We got mostly low-frequency anomalies happening here. Great indication of the South Atlantic anomaly, which is back where it was over the South American continent. And we'll let that play through one more time and bring up the latest image of the bridge between Earth and space, the F layer of the ionosphere. There's the latest image, 1230 Universal Time ionogram and 1230 Universal Time anomalygram. We'll also show the total electron content to show you the most likely places to see GPS errors. Your GPS satellites are at about 12,500 miles of altitude, and these are the free electrons in between your GPS satellite and your handset. So fairly normal here, considering we've got an ongoing coronal hole high-speed stream. We saw this very unorganized for an extended period of time, but it has returned to a less anomalous state. So most GPS errors occur around the equator at noontime. That's your coupled thermosphere, ionosphere, plasmasphere, electrodynamics model. Next, your latest intensitygram and latest colorized magnetogram. Do we have new sunspots up here? Any new sunspots there rising above the limb? Doesn't look like it. But we've got 1 and 2 new groups that should get a name today. Yeah, so we should at least have 2 new named sunspot groups today. We may see more forming groups there as well. Just make sure I have the latest. There we go. So some interesting areas of magnetic organization still happening here in the east. Some possible new sunspots forming in those areas. Again, at least 2 new groups likely to get names today. And it's time to continue on for our meteorology segment. So we used to separate all the videos, but we found that we actually get a lower number of views on YouTube when we do that for whatever reason. I have no idea why it works like that. The algorithms are completely nonsensical and ridiculous. And of course, the shadow bans are all too real. So if you enjoy the content, take a moment to visit our links. Press like, subscribe, share, etc. Smashomash.com is the official homepage of the Smash News Network, least busted name in news. And welcome to the Neo-Renaissance, as we are noting some major changes coming in the realm of heliophysics, astrophysics, and cosmology. Visit our playlists if you haven't seen those, as we do put out videos besides space weather content. You can find product reviews, some lifestyle stuff, and all sorts of other things in our playlists. Even some original music. Check out the 12 Days of Smashmas playlist if you haven't seen it. We released original music on the first 12 days of December. And we're in the realm of meteorology now, so let's take a look at dust. Yeah, dust. The equatorial Atlantic right now is quite dusty. As you can see, a bunch of dust here from the Sahara Desert fertilizing South America. And at the moment, not really the Caribbean, but it does. It does indeed fertilize the Caribbean and other islands, like these islands here, Réunion, and so on. So yeah, Saharan dust. That is, by the way, if you want to look at that yourself, that's on nullschool.net. That is the DUEX, which is Aerosols at the optical thickness of 550 nanometers. So dry air likely there over the central Atlantic, tamping down weather systems most likely, if there are any trying to form in that area. Dust. It prevents hurricanes. Yeah, dust. Anyway, let's take a look at the wind currents here. These are the surface winds of the eastern world. Shout out to our viewers from from over, and from all over the planet. These are the jet streams, this side of the planet. Jet streams of the western world looking like this. We've got a well-concentrated jet stream over the Great Lakes at the moment, and a divergence in the Atlantic. Also, we've got high pressure up here in between Iceland and Ireland. You can see that anticyclone, upper level high there, rotating clockwise. These are the surface winds. We've got a strong low off the coast of Northern California rotating counterclockwise. Surface winds of the central world are depicted here. And the jet streams depicted here. And blasting through some more weather, we've brought up the water vapor map today for the Americas. That'll show you all of the water vapor, not just the clouds and fog. It shows dry spots as well as wet spots. So that's what's going on in terms of water vapor. That's our water vapor satellite, part of the NASA GOES Interactive Weather Satellite Suite. And here's our weather.gov map. So if your location's lit, head to weather.gov and click on your location. We'll scroll down briefly to show you the key and then show you some forecasts. So a lot of weather warnings there. Some wind chill advisories in the north central U.S., some gale warnings around Hawaii. Likely some good surf down there. Some blizzard warnings continuing in parts of California, Nevada, and Montana. Actually, also northern Alaska. So here are some forecasts for the lower 48. That's your temperature anomaly forecast, and you can see very cold temperatures there in the north central. Southeast, some anomalously warm temperatures. Some very warm temperatures in the next 3 days coming to Missouri especially. Also southern Iowa, parts of Kansas. Could you imagine living in Kansas, folks? Just imagine living in Kansas. I mean, you've got hot air coming in from the west at all times. I mean, I guess it makes it less likely for a tornado to strike since cold air is largely responsible for the pressure gradients that create tornadoes. But imagine being downwind from all that Coloradan hot air, as that is a lot of hot air blowing out of Colorado. With emphasis on the word blowing. Blowing at forecasting. Yeah, blowing at forecasting. How about that? Next, our pressure and precipitation forecast. This is the same model that we showed you the temperature anomaly, by the way. This is the GFS 72-hour. And heavy, heavy snows coming, especially to California. Also heavy rains in the southern part of the state. Dag. That is quite a bit of precipitation. And let's check out the snow expectations. So this is the GFS 72-hour accumulated snow depth. And yeah, expecting 3+ feet in large portions of California. Also some snow coming to Pennsylvania here. So anyway, once again, that's your 72-hour GFS positive accumulated snow depth change in inches. And we'll also show you the windy.com imagery here to show you the difference between the Euro and the GFS model. So that's the Euro model. And there's the GFS. Once again, Euro model. GFS. We'll stay zoomed out. Euro, GFS for the next 3 days of new snow. Next, looking at lightning. Arkansas saw some thunderstorms, as well as northeastern Texas and southeastern Oklahoma. Do we have any active strikes at the moment? We'll consult lightningmaps.org to check on that. And indeed, we don't. It's actually quite calm here. Not a lot of lightning, at least detected lightning. And we actually had some strikes happen as we streamed the video here. So right around San Luis Obispo Airport, there's Arroyo Grande. There's thunder rolling in. Little thunder shower happening there northwest of Santa Maria. Anyway, continuing on to show some more real-time data, we'll briefly zoom out to show the full 50 states of ALSA, former nation, now Banana Republic, the allegedly United States of America. I don't know what's united about them. Think about Texas and Illinois. How united are those? Not very united. Or think about Texas and New Jersey. That's a great example. Yeah, real united. Texas and New Jersey, united by feds who can barely get out of their own way. Next, the lower 48. We've got some lake effects looking snow there, at least around New York and Erie, Pennsylvania. Heavy precipitation in California as that low hanging out off the coast is driving weather. You'll be able to see how cloudy it is down there, and you can see that rotating low there off the coast of Northern California. That's our shortwave radiation map that shows clouds and fog. Also some low clouds here over the North Atlantic. Some persistent low clouds there. And here is our water vapor map to close out this video. So hopefully that clarifies things. Here's your recap, U.S. Doppler radar. Shout out to Ricky, Julian, and Bubbles. You've got some sloppy weather there around Halifax. There is clouds and fog. And it's very cloudy over California at the moment. And last but not least, there is water vapor. You can see a bunch of moisture there being churned in from the Pacific, inundating the state of California once again. So thanks for tuning into the Smash News Network, least busted name in news. Please inundate our comments section and our likes. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.